Hello, it's Friday evening, and of course the big situation we're watching is Hurricane Matthew, but here in Texas, looks very much like fall here. Skies are getting really red and vegetation is getting all dry. We had the front come through pretty dry here. This is what Matthew looks like right now. It's now working up the coast into the offshore area of Georgia. Let me get my drawing tool set up here and we'll take a look at that. There you go. So there's the center of the storm right there, just off the coast of Georgia. But let's start out right now with what's happening elsewhere in the country. This will give us kind of a good baseline for what's happening weather-wise. We've got that front that has pushed through Texas, and we've got north winds across much of the state. And you can see it earlier today. This is the front pushing southward. See it right there along that line of cumulus. This is all tropical cumulus here. In the air back behind it, this is all drier outflow air from storms we had up in Texas last night. And these are the remnants of those storms right here. Mostly just high-based cumulonimbus and cirrus and altocumulus. Let's take a look at the synoptic scale picture and do our top-down analysis of weather conditions. And what we got going on, first of all, let me point out, for those of you who have never seen this webcast, this week, at least for this week, we're starting out with thickness. And thickness, that's these red dashed lines, like you see here. And a couple of them are blue to indicate much cooler thickness values. And by thickness, this is basically just an average of temperatures in the lowest 5 kilometers. A good way of getting that average temperature is just to measure the distance between the layer where our barometer would read 500 millibars, which is about 14 inches of mercury, and 1,000, which is pretty close to the ground. So what this is telling us is we have very warm air in this area and in this area here. And by contrast, we have very cool air in this area where the thickness lines punch southward. And what we're really interested in is the gradient, where we have packing of those thickness lines like this here. And using that, we can kind of pick out exactly where our surface front is. So it's going to run something like that. We know it's already clear Texas, so we can just kind of draw the marks for a cold front. And then the warm front would look something like this. It's all the way up near Quebec City, all the way up to James Bay. And back behind it, we've just got high pressure moving in. So there's a big 1028 millibar high bringing in cool air into the backside of that system. And looks like nothing off the Pacific coast, maybe a weak frontal system in this area near Seattle. Might be a bit of a front in that region. And further out to the east, maybe the tail end of a front there. So that is the overall picture, and we actually have kind of a much stronger high pressure system up in the Canadian north. So that's helping to feed even more cool air southward. And you can see Hurricane Matthew right out here. It's sitting out in the tropical air mass. And it's trying to move northward, but it's moving into this old stagnant polar high, which is sitting off the Maine coast. So that high is blowing out this cool air, kind of diverging in all directions. And when hurricanes move into a system like that, they try to steer around it. So we would see that either go more northeastward or around the backside. And we'll get into all the forecast stuff in just a minute here. Let's take a look at the upper air chart. We haven't really done that in a while. Before I do that, I need to, let's see, get rid of that and then move the window up so you can see a little bit better there. So this is the upper air chart for tonight. Now remember, we had the surface front looking let's see, it was something like this. And then we had the warm front like this. And the surface high was kind of like that. And then we had another high off the Maine coast. And this shows a very important relationship between the upper air patterns and the surface patterns. What you're looking at here is the 200 millibar flow. This is up at 39,000 feet. And what this is showing is that we have a jet stream crossing over the main baroclinic area of that frontal system right here. And by baroclinic, I kind of mean where the temperature contrasts are the strongest. And that's also where the most northward push of warm area is at the surface. So it kind of all focuses in that area. And the polar front jet is right above that. And then we have this other jet here to the south. This is probably more of a subtropical jet. And you can see that goes off the Carolina coast, or off the New Jersey coast, actually. And just a quick look at that. Let's take a look at the sounding for Fort Worth. Now, Fort Worth did have thunderstorms earlier this morning, so that's going to interfere with the profile a little bit. But off to the right here, you can see we had northerly winds from the surface up to about 800 millibars. That's about 6,000 to 7,000 feet. And above that, we had southwesterly flow. So we're seeing a little bit of that deeper cool air close to the surface, and above that, that's the more tropical air up here. And you can see we don't quite reach the stronger winds until we get up to about 200 millibars. Yeah, that's about 39,000 feet. Below that, winds are pretty light. And that's an indicator that this is a subtropical jet and probably not a polar front jet. Okay, so let's move on, and we'll slowly come to Hurricane Matthew. This is the infrared satellite imagery, and you can see that's a dry front pushing into the Midwest here and into Texas. And down to the south, the polar front jet, remember, that's running something like this. And you can see a little bit of this lee side cirrus coming off the mountains of Mexico. Now, when we do have a lot of unstable air across Texas and moisture streaming up the Rio Grande, this can be a very important region for severe thunderstorm development. You get the strong upper-level winds, that shears. You get very strong bulk shears associated with those storms, and that can really steepen your capes and your instability. And that's something we often see in March, especially. That's a very important time for that. Let's see. Let's move on out to Matthew and check that out. There's Matthew coming up the coast. It's starting to entrain a lot of dry air from inland regions like that. So you're going to see that on that radar presentation. Switch back to that. So the circulation is becoming very asymmetric. You can see the south side of the storm very being hit pretty hard by that dry air coming in the backside. Matthew right now, better move the window here. Category 2, sustained winds 95 knots, which is 110 knots. Pressure is 948, that's about steady from yesterday. And this is a quick look at the close-up infrared satellite imagery. And you can see the bubbly appearance to the colder tops here. That's where your main convection is. And down to the south, we have more of a striated appearance, indicating that that's mostly just cirrus overcast. This is the polar orbiter imagery, taken about noon today. So there's Matthew, and we try to zoom in on the eye. Can't really see anything. But if you're resourceful, you can do a screenshot, pull that into PaintShot Pro, and do some wizardry with that, and I'll show you the filter that I used to get this. I went to Layers. Let me make sure this is coming out real quick. Hang on. Move some windows. There we go. Actually, I went to Colors, Adjust, and then Shadow, Highlight, Midtone, and Shadow. Okay. Then it came up with a screen, and I adjusted the shadow way up high. And that brings out the detail of the brighter colors. It brings up the contrast. And we get something like that, and you can really see the eye right there. Covered by a lot of cirrus overcast, but you can definitely see a little bit of a remnant of an inner eye wall. Looks like very potent cumulonimbus towers right there. Maybe some more cumulonimbus towers here. And the rest of this is going to be cirrus overcast. So working with tools like that, you can definitely pick out some interesting features. And this is actually the oldest program I have on the computer. If I go to About Paint Shop Pro, this is let me try that again. This is a 1998 program, but it still works. Some software is always good. So that's one of the tools I use. It's simple and does the job, and that can help you with your analysis, certainly. And that leads us into the models. Let's see, let me check here, make sure my audio is okay. Okay, everything looks good. All right, one thing that we're concerned with is model performance. I like to go back and look at the last 2 days of models. And you can see here, this is back when Hurricane Matthew was coming out of Cuba and towards the Bahamas. This was about 2 days ago. So which models did better with this? Well, I took some notes earlier today, and I'm going to just kind of summarize really quickly. Back then, actually the Canadian model and the GFDL model appeared to have this pretty accurately, and also the UK Met model. I had been pointing out that the GFS model seemed to have the best handle, but it seems like in hindsight it was actually going a little bit too far to the left, a little bit more onshore. And I don't know if I just missed that or if maybe the data set's changed or something like that, but it's showing that, the Canadian model, GFDL and UK Met model kind of had this right on target. Then the next day, October 6th, you can see the hurricane coming up into the Miami area. And again, the Canadian model, UK Met model, and the GFDL model had this pretty close. So it kind of looks like that's probably what we should go with for today. Let me switch my screens out, make sure you can see everything. Okay. So let's take a look at this. Which one is the Canadian model? I'm going to flash this really quickly. You're going to see one of the lines start blinking a little bit. There you go. So the Canadian model is going more inland and to the left, which is noteworthy. Then the UK Met model, it's going to be this one here. So that's more of maybe a little bit to the right at first, but then it goes more towards the center as it gets close to Charleston. And let's see, what was the other one? The GFDL. Let's check that out. GFDL model, that's more of a median track. It's kind of right in the center of all this. Let me zoom in a bit here and you can see that. Make sure you can see Charleston. There's the GFDL right there. So all of these models are wanting to take it onshore or very close to the shore. The official National Weather Service or the NOAA forecast from NHC, that's going like that, so a little bit more offshore. And they're also keeping the intensities up higher, keeping this a Cat 1 to Cat 2 hurricane. But the model's bringing it inland. They're diminishing it below hurricane status down into the tropical storm region. So what happens is going to depend a lot on the track. If it comes onshore, frictional effects will tend to kill the storm and cause filling and degrade the wind field. If it stays offshore, that'll keep it a little bit on the stronger side. Now, one other data point we can look at. you can see they plot the model, they plot the location of Hurricane Matthew, and the latest data we have is 18Z, which is about 2 p.m. Eastern. But we have newer data. We've got this radar imagery, and we can get the latitude and longitude. So let's do that real quick. Down on the bottom, we have a readout of lat and long. All we have to do is set the cursor approximately where the center is. This tends to be tricky because sometimes you do have oscillation going on. You might have a double eye wall. That's not very clear. I'm getting about 30.8 and 80.5, maybe 80.6. So where's that on this plot? We can verify the models from earlier today. 37 is going to be here, 85, that's going to be in this region right there. So you can see that the hurricane is going a little bit, just a tiny bit to the right, maybe about 10 miles to the right from 7 hours ago. So the main clustering of the models is just a little bit to the left. And these outliers here, these are going to be the UK Met model. So the UK Met model has apparently seen a little bit of the rightward progression. And then the other one is going to be the no gaps. And the other one is the NAM, which has kind of been out to lunch the past several days. And, you know, it's not really a tropical model at all, so that's not very surprising. So the UK Met model, it even brings that very close to the coast, just 4 miles off the coast for the center. And that's enough to bring the left side eye wall into the Charleston area. Now that should be kind of on the weaker side because the forward motion is subtracted from the rotational motion. So if you subtract 15, 20 knots of motion off of, say, sustained 90 knots, that takes you down into the 70 knot range. And probably even with friction, that's going to cut it down even more. So if you're in the path of this, I'm not going to worry too much, but of course you do want to take your appropriate precautions. And that brings us to what happens after we scrape the coast here. Some of the models are taking it to the northeast. Some are going to the south, recurving it to the south like that. So there's a lot of uncertainty in the model prediction past about 72 hours. So a lot could really happen. The only dynamical models that are carrying it northeast are the GFDL, the COAMPS, UK Met, and the HWRF, and the others are bringing that back into the Bahamas. Fortunately, it will be on the weak side if it does go to the southwest, because the ocean surface temperatures are a bit cooler in that area after the hurricane, having passed over that area, has cooled that down. So the threat should go down quite a bit after about 72 hours. But when will this affect Charleston? Let's take a look very quickly at the model points. UK Met has got that passing Charleston at the 24-hour point from 12Z yesterday. So that's going to be about 6 in the morning, 7 in the morning. The no gaps, same thing, 7 in the morning. The COAMPS, 7 in the morning. Yeah, so this is going to pass by Charleston during the morning hours, right around dawn. And then we should see that track back offshore again. Maybe grazing Wilmington there as it comes north, but it should be even weaker by the time it gets out there. Okay, let's see here. Somebody asked about the sea surface temperatures, how much they cooled in the last few days. That's a good question. I'd have to pull up that product and take a look. We can probably do that and see. Sea surface temperatures for the Atlantic. I don't think I have that bookmarked. We'll take a look at this one from NOAA here. October 6th. That's going to be yesterday. That's probably not going to be good to go off of. I'm not actually sure we have good measurements yet, but I'll try to take a look here real quick. Yeah, this is probably about as good as we're going to get here. This is a blended chart. Yeah, this is October 6th. I don't think we really have any data. We'd have to go and look at some of the oceanic models. Probably the best one to look at would be the GFDL, and the Navy has that on some of their website pages, so I would go with that for now. So let's see, where are we at in our product list? Yeah, time for the forecast here. So let's check out what's going to happen in the next few weeks, or yeah, in the next few weeks, at least through mid-October. Starting out with that front coming into Ohio, into Arkansas and Texas. We remember that from earlier when I plotted that, and there's Matthew. And then we run this forward. So going into Saturday and then Sunday, we've got Matthew offshore. Some of that front starting to get caught up with Matthew. So we're turning it into kind of a hybrid thermal structure. We have a new low pressure system coming through Montana and the Dakotas. Looks like that'll mostly affect the Great Lakes region here. So going into next week, start picking up a little bit of a southerly flow across Texas and the plains. So the moisture will be back, but it should be recirculated flow from the Gulf, so it should be on the cool side. Then it looks like we get a new outbreak coming into the plains. This is around Tuesday. Then Wednesday, and then Thursday, cold front coming into the Midwest again and into Texas. So another frontal passage 6 days from now. And this should be a little bit stronger than the current one. And then when we get out to past next weekend, we get an even cooler shot coming into the Northeast. This is around October 21st. And here they bring the line associated with 20s and 30s temperatures all the way into the Northeast U.S. And then there's another shot later on. I've mentioned that the GFS does have a cold bias, so it may very well back away from this, but that is going to be something to watch. So I think we're finally going to be seeing fall arrive in earnest about a week from now, about a week to a week and a half. So that'll give us even more stuff to look at on these charts. One little footnote here. We've got a very mild meteor shower for tonight. The Draconids are going to be, let me see if I can bring up the image for that. There we go. That's going to be kind of a weak meteor shower. We're only talking about 10 meteors per hour. But of course that means, you'll probably see a meteor about every 6 to 7 minutes. Those are going to be radiating from Draco, which is going to be overhead during the early evening and to the north during the late evening. So this isn't a meteor shower where you have to wait until after midnight. This is going to be out all night. So you just look to the Big Dipper and then follow that pan out to Polaris. I can't draw on this because the way the software is set up. But yeah, you draw that line out there and then look up and you'll find the snake-like constellation of Draco. And that's where your meteors should be radiating from. And then, of course, next month we get into the Leonids. And those are sometimes a very, very big meteor shower. And there was one I saw back in 2002, I think. That was simply incredible. We were seeing meteors about every half second to 1 second. But tonight that'll be nothing like that. So anyway. All right, guys, I think I'm done for tonight. I appreciate you watching, and I'll see you tomorrow at the usual time, 8 o'clock. All right, good night.